classified paper 6 topic rate of the cooling questions. This is a common topic in paper 6. You will find a question, at least a question in a paper from this topic. These are the key points you should go through before starting the solution. So starting with the first question is actually planning experiment. And whenever you plan an experiment, what you should do, you should try to answer the points which are mentioned in the question. Like, and this question is of 7 March. A student suggests that the area of a water surface will affect the rate of a cooling of a hot water. Like if we change the surface area, the rate of the cooling, the time it will take to cool down, that will change for a hot water. We have to plan an experiment to investigate the relation between the surface area and the rate of the cooling. Write a plan for the experiment, include the apparatus needed. What are the things needed for this experiment if you want to do or carry out this experiment? You can use your mic, you can use the chat to say.
Thermometer.
Thermometer. What else? Container with different surface area.
Stopwatch or timer.
A stopwatch or a timer. A supply of a hot water. Like we should have a hot water supply. So usually, like example, for this set of different size containers or container of different size, thermometer and a stopwatch. Cylinder to measure the volume. That's, yeah, measuring cylinder to measure the volume. That's also true. So we need a thermometer. And whenever something is related to rate, it means we need a timer or a stopwatch. We need measuring cylinder or to measure the amount of the water which we use for this experiment. And we need different size beakers. Why different size beakers are there? So that we can change the surface area. That is one thing. So whenever, as I mentioned, whenever you write this experiment, there's a space available here. There's a space available here. You can write this all. And diagram is not required, but you may draw. So whenever a question is there, you may draw. Then you should draw so that in case if you miss a point, you will get the mark from that. Insulating material, we don't, because we are investigating how surface area affect the rate of the cooling. So even we don't have insulation because we are keeping the same for all the beakers. Either all are without insulation or all are with insulation. So that's why we don't need insulation for it. So what actually we will do, we will take a hot water. We will pour that hot water into a beaker. Then we record the initial temperature. And we start the timer and we record the temperature for 3 minutes. Rate of cooling can be affected by different parameters, but because we are investigating how the surface area is affecting the rate of cooling, so we'll repeat the procedure, but with a different size beaker. For all the beakers, we don't need insulation here. Why we don't need insulation? Because insulation is not the parameter which we are investigating. So we don't need insulation here. Why? Because if there is no insulation for beaker A, there is no insulation for beaker B. So they are like fair comparison. If I mention insulation, so I have to insulate beaker A, then I have to use insulate beaker B as well. But the question is investigating how the rate of a cooling is affected by surface area, so no need for insulation. How you'll obtain range of surface area? How we change the surface areas? How we'll have different range of surface areas?
By bringing different beakers.
A container of different size and width or different volumes, we can also say, by using containers of different widths, different size. Vary the we are using a beaker here as a container, measuring cylinder, because different volume containers have different surface areas. Like if you have a 50 cm cube beaker, you have a 100 cm cube beaker, you have a 200 cm cube beaker, they all have different size. But what we will do, we'll take equal volume of the liquid. Like we took example 10 cm cube of liquid in 50, we took 10 cm cube of liquid in 100, we'll take 10 cm cube of liquid in 200. Then instruction to carry out this experiment. How we do this experiment? So what we will do, we will pour or add, like example 10 cm cube hot water in example 50 cm cube beaker. So we add 10 cm cube of a hot water in 50 cm cube beaker. Like the maximum capacity is 50, but we just only added 10 cm cube of a hot water. Then we will record the initial temperature, or the starting temperature. Then start the timer and record temperature for 3 minutes for with 30-second interval. And then we will repeat with other beakers or beakers with other different surface area. Then what measurements we have to take? So we have to measure the initial temperature, the starting temperature, we have to measure the final temperature, and we have to measure the time as well, time interval. So measurements we have to take the starting temperature, or you can also mention only temperature because we are measuring a different temperature. So temperature and time. These are the two things which we have to measure. The precaution you will take to ensure that the initial results.
Same temperature of water and the same amount or volume.
Yeah. So you should use same amount of hot water.
Same initial temperature.
Same initial temperature. What else? Any other parameter should be same?
Same time.
Same time
Same
interval?
thermometer.
Same thermometer or same position of a thermometer is okay. A very important part is same room temperature, surrounding temperature. The parameter which should be kept constant, same room temperature or the lab temperature as we are doing in the lab. If you mention 3 are enough. What is the meaning of recording a temperature for 3 minutes with a 30-second interval? What does it mean? That's what we did when we start the experiment. We measure the temperature. Like when we at the beginning of experiment, maybe temperature of hot water was 80. Then after 30 seconds, we measure the temperature again. It might be say 72. Then after another 30 seconds, we measure the temperature again. It might be 66. Then after another 30 seconds, we measure the temperature. It might be 64. Like this, we continue to record the temperature after 30-second interval for 3 minutes, which is 180 seconds. The graph you will plot from your result, and you should sketch the axes with appropriate label. So what will be the graph we will plot? So it should be temperature and time. So there should be time on x-axis.
On x-axis temperature.
Time on x-axis. Like usually independent variables on x-axis. So time is independent variable. That's why it's on x-axis, and temperature on y-axis. Whenever the question is here, like you should sketch the axis here, means you have to mention like which quantity and what is the unit for that quantity. And what will be the likely shape of the graph? Likely shape of the graph, it will be like this. Like the slope here always represent the rate of the cooling. Is it clear, this experiment?
Yes, sir, clear.
Yes, sir, clear.
The initial temperature, yes, it affects the rate of cooling. If an initial temperature is higher, the substance rate of cooling is much higher. Like example, it will cool down much faster. Like if anything is say at 80 degrees and another thing initial temperature is 60, the rate at which the temperature decrease for 80 will be higher than for 60.